Hello everyone, and welcome to lesson 2.8, which is on dividing rational numbers. A couple things from this section carry over from section 2.6, which was on multiplying rational numbers. Those two things are, one, we do not have to have common denominators in order to divide, so that saves ourselves some time here. And also, rational numbers are any numbers that can be written as fractions. So some of the things we talked about in 2.6 will come back here, but if we can remember that we're dealing with fractions, number one, and then number two, that we do not have to have common denominators, we're going to be in good shape. Now, before we get into how to actually divide fractions, what we need to take a look at are a couple terms. The first term is reciprocal. That just means flip the fraction upside down. So for example, if I had the fraction 2 over 3, the reciprocal of that would be 3 over 2. We just flip the numbers upside down, have them trade places a bit, and we're done. The next number, or the next word that we have here is a term called multiplicative inverse. Now, while that seems complicated, really that's just another word for reciprocal. The reason why in math we use the term multiplicative inverse is because when you multiply a number by its multiplicative inverse, you get 1. So, in the numbers that I've already written, we've shown that 2/3 and 3/2 are reciprocals of each other. They're also multiplicative inverses because when we go to multiply them, if we remember from 2/6, we just multiply across the top and across the bottom. That ends up giving me 6 over 6, which can be simplified to 1. So now we understand what reciprocals are. We understand what multiplicative inverses are. The last thing that we have is a term called opposite reciprocals, or sometimes they're called negative reciprocals. Basically, that requires you to do two things. We have to flip the fraction, and we have to change the sign. So, for example, if I had the original fraction of 5 over 7, the opposite reciprocal or negative reciprocal of that would be 7 over 5 with a negative sign. So, the sign has to change from positive to negative or negative to positive, and the numbers have to trade spots. So that's what an opposite reciprocal or a negative reciprocal is. All right. Now that we understand those terms, we can move on to actually showing how to solve and divide fractions. To solve, I like to remember our good old friend KFC, Kentucky Fried Chicken, right? We know it, we love it, but if we can remember KFC, we can remember how to divide fractions. So, to divide, we are going to keep the first fraction. Then, we are going to flip the second fraction. And the third thing is we are going to change the sign to multiplication. All right, so keep, flip, change, KFC. Keep the first fraction the way that it is, flip the second fraction upside down, and 3, we're going to change the division to multiplication. So let's take a look at how that works in our very first problem here. We have the problem 1/3 divided by 4/7. So if I am to solve this problem, I need to keep the first fraction the way that it is. So I'm going to keep that as 1/3. I'm going to flip the second fraction upside down. So I'm going to do the reciprocal, which is going to be 7 over 4. And then I'm going to change the division sign to multiplication. Now that I've done that, I just have a multiplication problem, and we already know how to solve that. 1 times 7, 3 times 4, that ends up giving me 7 over 12, which cannot be reduced, so that is my answer. Okay, so sometimes division problems will not be written out the way that we would like it to be. And so example problems 2 and 3 kind of illustrate that, and we're just going to show you how to handle those situations. All it takes is just a little bit of rewriting, and we can go from there. So question number 2, or example problem number 2, says 8 divided by negative 1/4. So the way that looks, it looks like it's a mess, right? It just looks super complicated because we have 2 division bars and then like a fraction in a fraction, which is kind of messy. But if we remember that this bar here, yes, it's a fraction bar, but it's also division. And so if we know that, this problem can be read as 8 divided by negative 1/4. So if I can write it the way that we have it in the problem, I can also rewrite it like this. 8 divided by negative 1/4. Well, we know how to change whole numbers into fractions. That's just 8 over 1. And now we do our KFC rule. We keep the first. We flip the second. And we change the division sign to multiplication. All right? Doing that, I end up getting 32 over negative 1. And that just simplifies to negative 32. All right, so at first glance, a problem that is really complicated looks crazy difficult. But as soon as we rewrite it into a format that we can understand and we know how to handle, we're in perfect shape. So sometimes if you get these problems this way, just rewrite it and then you're okay. Our third problem kind of ties back into section 2.7, which was long division. No, I do not expect you to long divide with a fraction, but again, we just have to rewrite the problem. So this problem is 2,000 divided by 1/4. So all we have to do is the same thing that we did in example 2. We just rewrite. So we have 2,000, and we are going to divide that by 1/4. 2,000 as a fraction is 2,000 over 1. And now we can use our KFC rule, right? We keep the first. We flip the second. And we change the sign to multiplication. So that ends up giving me 2,000 times 4, which is 8,000. 1 times 1 is just 1. And 8,000 over 1 simplifies to 8,000. And that is how we divide. It seems like it's just as straightforward as moving some things around and doing some multiplication. Okay, our last problem here, and I'm going to switch colors just to make it stand out a little more. It says the area of a pan is 23 3/4 inches. If the width is 10.5 inches, how long is the length? So these type of word problems can play a big role into what we do in solving. And I get that anytime we have word problems, people kind of freak out. But the best advice I can give is read the problem one time, stop, read it again, kind of get an idea of what's going on, and then go from there. Right? We can pull out important numbers, we can draw a picture, we can do a lot of things. In this problem, it says the area of a pan is 23 3/4 inches. So we're just going to assume that we have a square pan here, and we have the area of the pan. Now we know the area equals length times width, so we're multiplying something. If the entire area is 23 3/4 inches, right, that's where we start. The next sentence says if the width is 10.5, so that means this is 10.5, how long is the length? Well, like we said before, area is length times width. So all I have to do is multiply 10.5 times some number to get 23 3/4. Well, how do I figure out what that missing number is? Well, if I can't multiply, I could work backwards and divide. So I could say, hey, 23 3/4 divided by 10.5 is going to get me my answer. So again, we have to go back and convert these mixed numbers, right? We end up getting 4 times 23, which is 92. And then we're going to add on to that 3, which would end up being 95 over 4. That is going to end up being divided by 10 times 2, which is 20, plus 1, which is 21 over 2. If you need a review on how to convert those mixed numbers again, and what I just did very quickly didn't make sense, go back and check out the video from lesson 2.6 because that has a more in-depth explanation and all the rules are written out there. From here, now that we have that problem, all we have to do is go through the multiplication process. So we're going to keep the first. We're going to flip the second. We're going to change the sign. So that ends up giving me 95 times 2, which is 190. And 4 times 21, which is 84. Now, 190 over 84 can be reduced. It can be reduced to 95 over 42. And then now we try to think and see if 95 and 42 can be reduced anymore. It can't. And so this answer here would be your final answer. If you really wanted to put it into mixed numbers, you could long divide that out and get the mixed number answer as well. But just for point of reference, 95 divided by 42 comes out to just a little over 2. It's like 2 and let's see. Let's call it 2 and 11/40 seconds if you wanted to convert that back out. But that process is not as important. So hopefully this has given you some very quick ways to solve these problems no matter what the division format is in. If you have any questions over the process, if you have any questions over the last problem, especially because it was a word problem, or even the converting process back from an improper fraction to a mixed number, please reach out and let me know. I'll be glad to help.